Hello, Hornets. Welcome and thank you for joining me today. Today's discussion is going to be on verifying identities. So what we're going to be doing is taking a look at the identities that you'll see in front of you. So you'll notice we're going to be working with verifying that 1 plus tangent x divided by secant x is actually sine x plus cosine x. We're then going to be taking a look at the negative cosecant squared x times the cosine squared of x is really the negative cotangent squared x. We're going to finish on the first group with sine squared x divided by secant x is really cosine x divided by cosecant squared x. Now, the way you want to do verifying identities is generally you're going to divide it into two sides. One side is going to be the sine of x plus the cosine of x. The other side, we're going to have the 1 plus tangent x divided by secant x. Now you'll notice I put that line down the center. This is to remind me that I'm not allowed to use the law of equality. I can substitute with identities, with a direct substitution, and I can factor. I can even multiply things together, but I cannot, under any extreme or any circumstance, use the law of equality. So when we're looking at this, when you see a fraction, it is often easier to simply separate the fraction into its two parts. In this case, I'm going to separate it into 1 plus tangent of x, and I'm going to go divided by secant x. Now, once I have this, I'm going to change the tangent x into sine over cosine, and I'm going to change the secant x into its identity, 1 over cosine x. Now, it requires practice for you to get used to these things, but sometimes it's just easier to always convert it into terms of sine and cosine if you have no choice or you have no idea what to do. So if I didn't have an idea of what to do, by separating the two and replacing the secant with 1 over cosine x, by taking away the tangent of x and turning it into sine of x over cosine of x, the next logical step is for me to get the common denominator. That means that I'm going to be adding 1, which is really cosine of x over cosine of x. I have plus sine of x over cosine of x, and when I divide by a fraction, I multiply by the reciprocal. So the reciprocal of the fraction 1 over cosine is cosine. I'm now going to get the common denominator, which I've already located. And if you recall, when we have a sum of two fractions, we have the common denominator on the bottom and the sum on the top. We're then multiplying by the cosine of x, and the cosine of x will reduce, leaving me with cosine of x plus sine of x. Now you'll notice they're not yet equal. And because they're not yet equal, I'm going to use the commutative property of addition to get sine of x plus cosine of x, and I now have my equivalent statement. Notice I have just demonstrated by using identities and the substitution method that 1 plus tangent x divided by secant x is indeed sine of x plus cosine of x. This is verifying identities. Let's take a look at the second one now. So we're going to start off in the same vein where I'm just going to go ahead and I'm going to separate it. So I have negative cosecant of squared x, cotangent squared x, and there's a product, equals, separated into its two sides, and on the left, or the right side, excuse me, you'll notice what I'm trying to get, a negative cotan squared x. So I'm going to start by using my identity, which says that the cosecant is really 1 over sine. Now you'll notice I'm going to factor out the square so that I can do this nice and easily. I then have times cosine squared x, and it's going to remain the same. This then will simplify into negative 1 over sine squared x times cosine squared x over 1. And when I multiply, I'm left with cosine squared x divided by sine squared x with a negative directly in front. Now you'll notice we know that cosine squared x divided by sine squared x is simply cotangent squared x. So I'm going to now do that replacement with my ratio identity and get cotangent squared of x. Notice they are now equivalent, and I have verified the identity. And therefore, negative cosecant squared x cosine squared x is indeed negative cotangent squared x. Number 3. We're now going to follow along with the same thing, and you'll notice two sides equal in between. I am not allowed to use the law of equality, so I'm trying to get cosine of x divided by the cosecant squared of x. I have to start at sine squared x divided by secant x. I'm going to go ahead and I'm going to separate it so that I have the sine squared x times my 1 over secant x. I'm now going to continue by, let's factor out and do sine of x, the quantity squared. Once again, we are dividing by that, so I'm going to multiply by my reciprocal identity, and that's cosine of x. And now I can take the reciprocal, and I know that the 1 over sine is really, or sine of x is 1 over cosecant. Notice you have to know your identities fairly well in order to do this, and therefore you need to study your identities. If you aren't doing so, well, unfortunately, you're making yourself have a harder time at this than I would like. Now I'm going to quickly multiply them, and I get cosine of x divided by cosecant squared x. Notice that they are now equal, and I have verified my identity. And let's go ahead and turn the page and see the next group of 3 that we're going to work with. The next group of 3 has 1 plus tangent squared x is really equal to 1 over cosine squared x. Secant x plus cosine x is really cosine squared x plus 1 over cosine x. Then we're going to go to number 6. Secant x minus 1 over secant squared x is really cosine x times 1 minus sine x. We're going to finish this page with sine x cosecant x divided by cotangent squared x is really equal to the secant squared x minus 1. Alrighty, let's take a look at our first problem. Now, my goal is to make the left side look like the right side. Now, it is entirely possible that you might decide to make the right side look like the left side. That is still working with the verifying identities. The third operation is one that I do not like, but I have seen it used in the past. And that's where you work on both sides until you come up with something equal in the middle. And I find that to be one of the more difficult processes. Okay? Alrighty. So I want you to look at that. We're going to divide it into its two sides. Excuse me, as my throat gets a little dry. And what I'm going to do is I'm going to make sure my equal sign is in the middle and the line underneath it. On the right, I'm going to have the 1 over cosine squared x. On the left, I'm going to have 1 plus tangent squared x. And we know that 1 plus tangent squared x is really secant squared x. I also know that secant squared x is the reciprocal identity for 1 over cosine squared x. Now, if you wish, you can factor out the squared, then take the reciprocal and put it back in, but I see no reason to do so. Notice they are now equal, and we have verified the identity. For our next one, once again, divide it into its two sides. The right side is going to be the secant of the left side, is the secant of x plus the cosine of x. And the right side is going to be the cosine squared x plus 1 over cosine x. Now, when I work with this, I'm going to immediately use my reciprocal identity to get 1 over cosine of x plus cosine x. This is now going to allow me to find my common denominator by multiplying by 1. Cosine of x over cosine of x. I end up with 1 plus cosine squared x divided by cosine of x. You'll notice I now have things almost exactly what I want, but I need to flip it. This is caused by the commutative property of multiplication. Therefore, cosine squared x plus 1 divided by cosine of x is my final answer. And because they are equal, I have verified the identity. So you're either working with the right side or the left side. You can multiply by 1 and you can substitute identities, but you cannot use the law of equality. Let's take a look at number 6, please. So in number 6, divided into its two parts, cosine of x, 1 minus cosine of x. And if you wish, you can always work with the right side if you prefer to do that. I still like to work with the left side, and so that's what I'm going to do. So I have my secant of x minus 1 divided by the secant squared of x. And I'm going to want to make sure that I divide it into two parts. I'm going to divide it into two parts so that I can then have two easy pieces, secant x minus 1, and I want to make sure that I have divided by the secant squared x. Now, if you wish, you can immediately go to 1 over. Let's just go ahead and make sure I call it 1 over. Otherwise, it's going to change. So you'll notice, by 1 over, it's no longer divided by secant. So you would have to change that to a times. So you have your choice. If I use divided by, I write it as secant squared. If I say times, I call it 1 over secant squared. Once again, I prefer to call it divided by. This will allow me to now do my substitution, and I can then have the secant x, which I'm going to call 1 over cosine, and I have minus 1, and you'll notice I'm going to want to change that into the common denominator of cosine. We'll do that in the next step. I then have divided by what this secant squared actually is. It is 1 over cosine squared x. I'm now going to get the common denominator. 1 over cosine x minus cosine of x over cosine of x times the reciprocal cosine squared x. Getting the common denominator, I have 1 minus cosine of x. I'm dividing by cosine of x, and I have times cosine squared x over 1. The cosine power is going to cancel with the denominator, and you'll notice by the commutative property of multiplication, I can move the cosine to the front, so that I have the cosine of x times 1 minus cosine of x. And you'll notice that this is what I'm trying to get. And since they are now equal, I have verified the identity. The last problem that we have to do, and I am going to be leaving 3 of them for my students to do on their own to continue to practice in preparation for their check for understanding, which they're going to have at the end of this week. Once again, dividing it into two parts and a line in the middle, I have secant squared x minus 1. I then have my sine of x cosecant x divided by the cotangent squared x. Now, I'm going to go ahead and I'm going to call my cosecant 1 over, and I'm going to divide by the cotangent. So I have sine of x times 1 over the sine of x divided by the cotangent squared of x. Sine and cosine will reduce, leaving me with 1 divided by. I'm now going to call this, let's leave it as the cotan squared x. We're going to replace it with our divided by, and this is going to end up being our, let's just think about this a minute. Let's call this 1 over tangent, right? Because that's what a cotangent is. Keep our squared in there. Now when I replace it, I end up with 1 times tangent squared x. And we have an identity for what tangent squared x is. It happens to be secant squared x minus 1. Notice now they're exactly the same, and I have verified the identity. Now, this requires you to know your identities, and I cannot stress that enough. I'm not going to give them to you. You have to know them, and if you don't know them, you're making your life more difficult. So when verifying an identity, we can work on the left or we can work on the right and make the right side equal to the left side or the left side equal to the right side. Occasionally, a teacher will ask you to do both sides until you come up to some equivalency in the middle. Please remember, you may not use the law of equality. You may factor, you may multiply by an equivalent form of 1, or you can substitute your identities. Alrighty, this was verifying trigonometric identities, and I hope this made sense for you. Please remember, if you had any part of this that you struggled with, it is most likely an issue of your memory of the identities that are expected to be known. Okay? Now, if you'd like to remind yourself what those particular identities are, I would be more than happy to show you the beginning of chapter 5 where they are all located. They are right here. These identities you have to know by heart. All right? If you struggle with them, this could be more difficult than you want it to be. So the more you know them, the easier this is, and the more likely you will not make a silly mistake, because you'll be able to see that you made the mistake in the first place, because an identity will be out of place. Alrighty, this was verifying identities, and this is one of the things that we are continuing to work on throughout Chapter 5 of our pre-calculus with limits, so that we can make sure that we are able to move forward. Without being able to verify identities, we will find life a little bit more difficult when we have to solve. Alrighty, Hornets. Thank you very much for participating and listening to this. Please remember, if you find this was useful and you would like to let me know, click like, and that will give me an idea of how I'm doing. If, however, you find that there was a problem with this video, or you have suggestions for it, please feel free to put these suggestions into my YouTube page. And since I'm almost always taking a look at it, I'll be able to get your advice. And with that advice, I may even be able to improve, which is certainly what I'm always hoping to do. All right. Good night. Thank you. And please be well. Cheers, Hornets.